To study a polar bear in the wild, you first have to find one in millions of square miles of frozen terrain. Historically, this meant flying helicopters through punishing weather, tracking down an apex predator, and physically sedating the animal to take basic measurements. But time and ice are both running out. Polar bears rely on sea ice as their primary hunting platform. As that ice forms later and melts earlier, researchers need faster, more frequent population data to figure out if these animals are surviving the shift. Satellites and drones now capture vast stretches of the Arctic to monitor these changes. The problem is volume. They generate thousands of high-resolution images covering endless white landscapes, a scale far too massive for human researchers to scan manually. This is where artificial intelligence takes over. Using a technique called computer vision, AI models can instantly scan through thousands of blank white images and pinpoint slight anomalies or animal shapes faster than any human team could. It takes the physical struggle of searching the tundra and turns it into a rapid digital operation, allowing scientists to focus their attention exactly where the bears actually are. Knowing how many bears are out there is one thing. Understanding their individual lifespans, movement habits, and health usually required physical capture, tagging, or fitting them with radio collars. Now, computer vision models can act as non-invasive biometric scanners. By analyzing a photograph, the AI maps out facial structure, unique scars, ear shapes, and distinct fur patterns to distinguish one bear from another. This means researchers can track a specific bear's movements and estimate its physical condition through repeated camera sightings alone, without ever getting close enough to disturb it. Of course, a photograph cannot test blood chemistry, measure hormone levels, or provide genetic information. Visual analysis has strict limits and cannot replace a biological exam. Even so, the immediate benefit of AI at this micro level is clear. It gives scientists the data they need while radically reducing the need to physically disrupt the animals' lives. As sea ice retreats, the geography of the Arctic is shifting. Bears are forced to spend longer periods stranded on coastlines, bringing them dangerously close to human settlements. These communities are full of powerful attractants. A hungry bear will easily follow the scent of household waste, stored meat, or dog food right into a populated area, creating extreme risks for everyone involved. To prevent these encounters, communities are testing AI-powered camera traps along their borders. These systems are specifically trained to look at an approaching shape and distinguish a polar bear from a local dog, a person, or a vehicle. Instead of forcing local officials to watch hours of blank camera feeds, the system filters out the noise. It only sends an alert when a likely threat is actually detected. In these high-stakes coastal zones, giving a trained response team just a few minutes of early warning is often the only difference between safely scaring a bear away and a lethal encounter. Deploying delicate electronics in the Arctic comes with harsh realities. Heavy snow buries lenses, extreme cold drains batteries in hours, and the weather changes constantly. The algorithms themselves can also be easily fooled. An image recognition system might confidently label a bright rock, shifting shadows, or coastal seafoam as a polar bear, generating false alarms that train people to ignore the system. This is why human oversight and indigenous knowledge remain absolutely necessary. Local experts have to verify these automated detections, determine where to place the cameras, and provide the deep ecological context that remote sensing misses. Artificial intelligence is a fragile tool in a punishing landscape. It only functions well when guided by local people who understand the unpredictable reality of the ice. Zooming out to the planetary level, researchers use AI to model the future of the entire Arctic. These predictive models ingest massive data sets, like wind speeds, ocean temperatures, and historical climate records, to forecast where suitable bear habitats might remain. This data map shows the historical baseline of winter sea ice extent across the globe. AI models calculate how these exact boundaries will shrink and fragment under different warming scenarios over the coming decades. But there is a sharp contrast between the neat, orderly mathematical predictions generated on a screen and the chaotic, physical reality of a landscape actively breaking apart into the ocean. While these algorithms give scientists the most detailed picture of the future we have ever had, a beautifully rendered map of habitat loss cannot physically freeze water. There is also a hidden physical cost to this digital observation. AI models require massive data centers and physical servers to process this information. Training and running these computations demands enormous amounts of electricity. When that power comes from fossil fuels, the infrastructure generates greenhouse gases, adding to global warming. That atmospheric warming pressure directly forces the cracking and shrinking of the ice layer these animals depend on. It creates a troubling paradox. Relying on high-emission, power-hungry computing to track polar bears means the tool used to study the environmental crisis is actively contributing to it. Despite the intense excitement surrounding artificial intelligence, the biological reality of the animal is stark. No algorithm can provide a solid hunting platform, and no computer vision model can replace the calories required to survive. The technology is only valuable if it is tied to tangible emissions reductions and concrete habitat protection, rather than endless rounds of data collection. Polar bears do not need more advanced digital models documenting their decline. They need us to take the physical climate actions those models demand.